Thank you.
Good morning, Heights High School. This morning, AP French testers may be released and will report to room X205 in the Freshman Center.
No, it's chapter test review. I know, because we have a chapter test tomorrow.
205 in the Freshman Center.
Because we have a chapter test
This
tomorrow?
afternoon, we will have AP Environmental Science in
Test tomorrow?
the Fitness Center. AP
So we're going to talk about that. I have the final review. It's just over here.
to D129.
That's the final review.
Testers, make sure that you are in your room by 11:30. All testers need to make sure that they have an ID card on them. All AP testers need to make sure they have their student ID card on them. Thank you.
Awesome. And literally at this point, there's nothing they can do to change it. So
Yeah.
we do such good planning ahead. All right. Let's take a look at this bell work, and then we'll work through whatever we want to on the review. Because we got a chapter test tomorrow. You know.
Crap, I forgot to turn this in yesterday.
I'm going to turn it in today. What do we need to do first on something like this? Yep, we're going to need to factor that denominator. I see an x squared in there, and I'd really rather us not have one of them. So, what can we do? How could we factor that? It's a difference of squares. X squared is a perfect square, 9 is a perfect square. So we can use our difference of squares pattern, where I can rewrite this as our x plus 3 and x minus 3. So we can think about our denominator looking more like that. So if we want to be able to add these two fractions together, what do they need to have? What needs to be exactly the same? The denominators. So if I know that this right fraction already has an x plus 3, I need to make it match this one. So I need it to gain an x minus 3. So I'd really like it if I could write this denominator as our x plus 3 times the x minus 3. Yeah, we need to multiply it by a really weird looking 1 because we do not have an equal sign here. So I cannot multiply everybody by the denominator to make the denominators go away since there's not an equal sign. If there's an equal sign, absolutely multiply everybody by the denominators, get rid of all the fractions. We love it. If there's not an equal sign, we have to multiply by a funny looking 1. So that's going to give us our 3 over our x plus 3, x minus 3, plus, when we multiply these together, I am going to do this multiplication to get our x squared minus 3x over our x plus 3, x minus 3. And since we have the same denominator, we can add those together with our x plus 3, x minus 3 in our denominator. And our numerator, I'm just going to put everything in order because we are just adding things together. Our x squared, our minus 3x, and our plus 3. On the top, right here. That's because it's a difference of squares. So, oh, my iPad froze on me right there. Just a second. Since x squared is a perfect square and 9 is a perfect square, we can use that special pattern I'm going to make this just be slightly opaque so we can actually see through it. So we eliminated that out to put it as our difference of squares pattern. That was not the laser pointer. But if you don't notice that, or if you don't see that, you can absolutely still do this with our, well, a times c, 1 times -9 is -9. My b, I don't have any of them there. We've got 0. So multiplies make -9 and adds to make 0 would be +3 and -3, which will give you the exact same pieces.
Factor that. How?
Are you talking at the bottom?
Yeah.
It does not factor, but a good idea to check. Say that again? On the right-hand side? Yeah, we were trying to make the denominators match. This guy already had the +3, so we needed to give it a -3. And since I don't have an equal side where I can multiply both sides and get rid of fractions, I have to do it by the funny-looking one to make my denominators match. And since this guy down here doesn't factor any further, that's our answer right there. It's always a good idea to check, but there isn't a set of numbers that's going to multiply to make 3 and add to make -3. Yeah, no. So that's as good as it gets right there. And that's okay. Questions on this one? Okay. So what we're going to do today is we're going to look at the review. We have a chapter test tomorrow. I've got the whole review up here. You guys just let me know what you want to work through, and we can work through any of the questions on here that you want to see. Now is a great time to make sure we're ready for our very last chapter test. That is tomorrow. So what do you want to look at? Flip through it. See if you can find places where you got a little bit stuck. What's up, Arturo?
1B.
1B. Describing our transformations. We're going to have to do 1A before we can do 1B, but that's okay. Because we are going to practice putting a rational function that's written in quotient form into our transformation form. Because in order to describe our transformations, we got to have it like this. We got to have it in transformation form. So we're going to look at this guy right here. This is written in quotient form. It's 2 little polynomials, one on top of the other. And in order for us to get this into our transformation form, we need to actually divide this out. So we have done this with, that is the chunkiest pen. That looks so chunky here. That's just because it's taken the whole page and put it at the scale of the slides. And so I'm like, ooh, that's the ick. So we need to take our -4x, plus 14. And we need to divide that by our x minus 3. So in order to be able to write it in transformation form, we have to divide it down. Yes, thank you. Oh. It's just trying to run away from both of us. It's like, no, I don't want to go to school. No passes. I don't want to be a pass. Oh. It's okay. So we have to divide this down in order to get this into transformation form. So what number is going to go up here? -4, because we're looking at this first term and this first term. We want to know what we need to multiply this by to get exactly this, and that would be a -4. When we multiply our -4 times this piece and put it underneath, we're going to have our -4x. -4 times -3 gives us a +12. And then to go between our two lines here, we need to make sure we are subtracting everything. So -4x minus -4x gives us 0 x's. They cancel out. That is quite literally the whole point. If they don't cancel out, something went wrong, stop there. And then we have 14 minus 12, which is a 2. So I always kind of make a pit stop in what I consider like the mixed number format, because if we were to do this like with real numbers, it's a lot easier to remember that this is the big number, the whole number of times it went through. This is our remainder. So the whole number, that number of times it went in, that's the big number, our minus 4. Our remainder is the top of the fraction, and what we divided by is the bottom of the fraction. So we can think of it of negative 4 and 2 over x minus 3. That puts us into the transformation form just by switching those two pieces of 2 over x minus 3 plus negative 4 or minus 4. So this lets us put it into transformation form, and technically it would equal our f of x, or f of x equals, or y equals, to make it an equation. But if you just put the transformation form, I get it. But I'm just going to be technically correct. I would 100% take it like that. Technically this is better, but I'm not that petty. Technically this is better. So then let's look at part B, because that's really the guy we were wanting to look at. If we want to describe the transformations here, we're going to get our transformations from our A, H, and K. So we want to know what our A is. We want to know what our H is. And we want to know what our K is. So what do we see? What is going to be A or H or K? Say it again. Negative 4 is which one? K. Which means, what direction is that moving us?
Down 4.
Down 4. So we've got K. What else we got? A is 2. What does an A of 2 do for us? Stretch. Yes. What about H? 3. Good. Positive 3. What does that do? Which direction does it move us? It goes to the right 3. Exactly right. So when it says describe the transformation, that's what I mean. It went left how many, up how many, down how many, that kind of vibe. Questions on that part? And then let's do C, because we'll just finish this guy out because we're right here. Because our asymptotes are very much based on the things we have already. Our vertical asymptote, I was like, shoot, if all we had was those pieces, we could get our asymptotes. What's our vertical asymptote going to be?
X equals 3.
X equals H, X equals 3 in this case. And again, with our vertical asymptote, the way I kind of remember that is that V is going to sit kind of in the crook of the X pretty nicely right there. Because I draw my Y's all swoopy. So our horizontal axis, or our horizontal asymptote, we're going to have our Y equals what? -4. It's always going to be our Y equals K. So Y equals K is our horizontal asymptote. Vertical asymptote is X equals 3. So that's everything on question 1 right there. Questions on that one? What else would you guys like to look at? You guys get to drive this ship. Number 5. Solving. Yeah, that's a good one. Let's do B. I'll try B. All right, so this has some very similar pieces to some that were in our bell work problem today. So we've already looked at x squared minus 9 and how we can factor that. That's our difference of squares. So we can 100% do this either by taking our x with 1 times minus 9, adding to be 0 to find our positive 3 and negative 3. We can remember the difference of squares pattern. We can factor it in another way, but either way, our x squared minus 9 can be rewritten as our x plus 3 and x minus 3. So since we have an equal sign here, right here, we don't need to multiply by funky looking ones like we did in the bell work. I can find my least common denominator and multiply everybody by that to get rid of my fractions. So if we have an equal sign, we multiply everybody. If we have no equal sign, we multiply by funny looking ones. But that means we need to know what our common denominator is. So what is our least common denominator going to be on this guy?
X plus 3 and x minus 3.
Because we already have one of those pieces here, and we have one of those pieces here, and we have both pieces right there. So we need to make sure we include the x plus 3 and the x minus 3. So, there we go, just trying to make sure I don't run out of too much space. Oh. I'm just moving this up over here because I'm going to run out of space if I don't take advantage of that space to the side. So what I'm going to do is I'm going to take all of our fractions here and multiply it by our least common denominator. So I'm going to have my x, oh, hello, would you let me write? Thank you. X over x plus 3 that we're going to multiply by the x plus 3, x minus 3. And we have our 9 over x minus 3 that we're going to multiply by the x plus 3, x minus 3. And we have our minus 54 over x plus 3, x minus 3, times our least common denominator of x plus 3, x minus 3. So we multiply absolutely everybody by that common denominator. I know, I'm so funny. I'm the funniest ever. We got a test tomorrow and a final in a week. Watch humor at your own peril. Because now we've multiplied absolutely everybody by there, we can come through and simplify. This x plus 3, that is too clear. There we go. Making that small. This x plus 3 is going to cancel with that x plus 3. This x minus 3 is going to cancel with that x minus 3. And over here, my x plus 3 cancels out, and my x minus 3 cancels out. So we have a lot of things that cancel. We're going to be left in this left spot with my x times x minus 3, which I'm going to multiply this out. My screen is being a jerk. My x times x and my x times minus 3. So we're going to have x squared minus 3x equals, here we're left with our 9 times x plus 3. So we're going to have 9x plus 9 times 3 gives us 27. And then we have our everybody canceled out on the far right piece, so we have minus 54. So these get really, really long for about a line, and then a whole lot of stuff cancels out, and we have no more fractions. Questions on that part of it? Then let's look at this thing and solve this guy. What do we do to try and solve this? X squared minus 3x equals 9x plus 27 minus 54.
Well, first of all, we could combine the
Mm-hmm.
7 and do -54.
Let's combine some like terms. We've got our x squared minus 3x equals 9x. 27 minus 54 is a negative 27.
And then we would subtract the 2x and add the 3x to the other side. Right?
Subtract the what?
The x squared, that's what I meant. Brain.
I was going to say, we can subtract the x squared. In general, we want to try and keep our x squareds positive. So since we either have to move two things over here or two things over here, I'm just going to move everybody this way.
Okay.
Because when we have an x squared, we need to make this equal to 0. What's up?
Could you have added 3 to 1?
Yep, and we will. You can do that, but we want to get our x squareds just to be positive. So if you want to add your 3x this way, you're just going to have to subtract it over this way as well. You're going to get to the same answer. It doesn't matter which order you do it in. But since I know we have an x squared, I know I'm going to need to get this thing to be equal to 0. So I'm going to minus 9x from both sides, and I'm going to add 27 to both sides. So I'm going to do 2 steps at once here. That's going to give us our x squared. Minus 3x minus 9x gives us a minus 12x plus 27 equals 0. We've moved everybody over. Since we have an x squared, we need it to equal 0. And then let's see if we can factor this thing. We're going to use our x frame. My a is 1, my c is 27, so we're looking at 27 on the top and a negative 12 on the bottom. We want to see if we can come up with a pair of numbers that multiplies to make 27, adds to make negative 12. Since the top number is positive, we know they're both going to have the same sign. So since that bottom number is negative, we know they're both negative. So the pair of numbers that multiplies to make 27 and adds to make 12 is going to be 9 and 3. So that means I could write this in my factored form of x minus 3 and x minus 9. If you want to put it through the full box to get it into factored form, absolutely valid. But we can take our little shortcut since our a is 1. So what are we getting as our possible solutions here? What are our answers? Yeah. So we set each of these factors equal to 0. Our x minus 3 equals 0, and our x minus 9 equals 0, which gives us solutions at x equals positive 3 and x equals positive 9. So we have 2 possible solutions here. What we get to do now is check them. We have to go up and check them. Because my x equals 9, beautiful. So if I substitute 9 in here, 9 plus 3, definitely not 0. 9 minus 3, also not 0. 9 squared minus 9, also not 0. So my x equals 9 definitely checks out. What happens when we substitute our x of 3 in?
It does not work.
I was going to say,
The 3 plus 3 would work.
this one's just fine, but this guy gives us problems. If I put a 3 right here, we have a 0 in the denominator. 3 minus 3. Ew.
Same with us.
And this guy too, if I did 3 here, 3 squared minus 9, that's going to give us a 0 in the denominator. So this guy does not work. What do we call it when they do not work? Oh my gosh, they made us do all that work and it doesn't even count. They are so extra. Sebastian?
Yes.
That is when we have our extraneous.
Can I just put extra?
Yep.
Got it.
Extraneous. So the only answer we have that actually does work here is the x equals 9. So this is our solution, but this is important to also show that our x equals 3 is extra. Oh my gosh, so extra. Oh, I was. Look at A. Yeah. Very, very similar vibe for A. We're going to find our common denominator so that we can multiply absolutely everybody by it. We don't have any sums in here, no adding, no subtracting, so it's just like monomial terms. So let's see if we can figure out what pieces need to exist in our denominator to find that LCD, our least common denominator. We are going to need something that is a factor, that is a multiple of 2, but I'm actually not going to pick the 2. What other pieces do we notice in our denominator? Yep, we know we have an 8, so I'm going to take my biggest number here. So I'm going to grab the 8. And we have x's, but if I just multiply by 1x, am I going to get rid of all my x's? We need to multiply by 8x squared. If I multiply this term by 8x squared, my denominator is going to cancel out. If I multiply this term by 8x squared, my denominator will cancel out. If I multiply this term by 8x squared, my denominator will cancel out. That's what I need. I need the smallest thing that's going to make all of my denominators cancel out. And 8x squared is going to be our least common denominator. We don't want to go bigger than that because it winds up with like way too many x's in there. So what we're going to do is I'm going to take my negative 2 over my x squared times 8x squared plus our 1/2 times that 8x squared set equal to our negative 12 over 8x.
How does the 1/2 cancel out? The 2 cancels out with the...
Let's take a look. So on our very first one, on the blue one, my x squareds, we can see that pretty clearly because when we are multiplying these fractions, it's just like if I had one big old fraction here. The x squared is going to cancel out with the x squared, and we're left with negative 2 times 8, which is also known as negative 16, which I'm going to do in a different color. Again, this next fraction, it's like multiplying across 1 over 2 times 8x squared is the same as 1 times 8x squared over 2. So what can simplify here? What is 8 divided by 2? 4. So this becomes 1 times 4x squared, also known as 4x squared. And then on the right-hand side, we have our 8x. That's going to cancel out with the 8 and cancel out one of the x's. So we're left with a minus 12x. And at this point, it's very, very similar to the other one that we did, because we're left with something that has an x squared that we're trying to solve. Which means if I have an x squared I'm trying to solve, I need that thing to equal 0. So our first step is going to be to get everybody on the same side. So I'm going to add 12x to both sides. Remember, I cannot combine these two pieces together because I have an x squared and an x. I have a lot of people that have really randomly started really adding our x's together no matter what power things are. So remember, this is an apple, like a straight up apple fresh off the tree. This is a whole apple pie. They are related. They are not the same. Do not shove a whole raw apple in my apple pie. Do not shove an apple pie in my apple tree. Like, don't combine them together. They're related, I'll give you that, but they are not the same thing. Just a raw apple sitting in the center of my apple pie, I would be very sad. So this will give us our 4x squared plus 12x minus 16 equals 0. So do not add these guys together. They are not the same thing.
Do we take out the greatest common factor of 4?
Yes. So looking to try and factor this, a lot of times we will just instinctively go x and box and go. But we actually have a greatest common factor here first. It is important. It will make your factors wrong if you don't catch that. So we need to take out our greatest common factor, and we've already noticed that they're all divisible by 4. So if I divide a 4 out, we get 4 times our x squared plus 3x minus 4 equals 0. If I was to redistribute that 4 through, we'd get exactly what we had above. And then when we're trying to factor, we just get to look at this guy. Makes our life a whole lot easier because that is relevant to our shortcut. We can take that pathway. Our a times c, 1 times minus 4 goes at the top. Our 3 goes on the bottom. Looking for a pair of numbers. It multiplies to make negative 4, adds to make a positive 3. Positive 4 and negative 1. So we can rewrite this as our 4 times our x with the positive 4 and our x with the negative 1. So when we're looking for our solutions, these are our guys. Our x plus 4 equal to 0 and our x minus 1 equal to 0. Giving us possible solutions at what places? X equals negative 4 and x equals positive 1. So we need to go up and check them. So we'll go all the way back up to the beginning.
So at that point, we're just ignoring the 4.
It doesn't have any impact on where the roots are. The 4 out in front, what that does is that'll do a vertical stretch. So, but the x-intercepts, if we were to graph this quadratic with or without the 4, the x-intercepts wouldn't change. It would just be taller and skinnier with the 4 there. So we pull the GCF because he's in the way, but he doesn't actually change what's happening. So our x of minus 4, if I was to substitute that in here, we're good. If I substitute that in here, that's definitely not 0. So this guy checks out. Same thing that happens with our 1. If I put 1 in place of this x, 1 squared is not 0. 8 times 1 is not 0. So this one also checks. We get 2 answers on this guy. So it could be either x equals negative 4 or x equals 1. Both of those count as solutions. Part B only had 1 answer. Part A has 2 answers. And that can happen.
What about 0 answers?
That can happen. If I only get an extraneous solution, that just means there's no solution. That has happened. Number 4. Let's see if we can get through. Yeah, we should be able to get through number 4. That's one of the story problems. I was going to say, because we just have about 2 minutes left until the bell. Or until the announcement reminder. So we've got, very much like the ones we worked in the last couple of days, Jamie takes 40 minutes to clean the kitchen, and James can clean the same kitchen in 25 minutes. So if they work together, we want to know how long it would take them to clean it. So James can clean one kitchen. No, you're right. This is supposed to be Jamie. There we go. Jamie. Haha. To be fair, the names in one family being James and Jamie is slightly diabolical.
I know my friend, her name is Jamie, and she doesn't have any siblings that have the same.
I had a friend when I was about your age whose everyone in their family's name started with a P, including the pets. Pamela, Patrick, Patricia. Pickles and pumpkin.
Okay, no, eventually.
But James and Jamie is a little diabolical.
It's basically the female version of the name and the male version.
Yep. So if we take what it takes to clean one kitchen, that does say kitchen, it looks like kitten. And I want to know how long it takes them to work together. We need to add those two pieces together so we can figure out how long it takes them to clean our one kitchen in X minutes. So doing this as its own set of fractions, we're going to have our 1 over 40 plus our 1 over 25 equals our 1 over X. So we need to multiply everybody by our least common denominator, which I'm going to use my 40, my 25, and my X. You can absolutely do it with smaller numbers, but you don't have to. Times 40 times 25 times X times 40 times 25 times X times 40 times 25 times X. But that's going to let the 40s cancel out here, the 25s cancel here, and the X cancel here. That's going to turn into us getting 25X plus 40X equals 40 times 25, which I don't actually have at the top of my head. 1,000. Which we could finish solving that. We could combine our like terms and then divide, get our X by itself. I did it on the answer key with 200X as our least common denominator because 200 is divisible by 25 and 200 is divisible by 40. But you can absolutely do it just like this. Totally valid. Then go for it. That totally works. I'm going to pull up our announcements. Just because, you know, thing. Take 2 decimal places. It should be 15.38, I believe. Oh, I'm not gonna.
Here's a
I have to go. I have my son. Okay, email me. That's what I'm doing.